Okay, definition 2.1, type 1 region. Okay, we have two types of integration here. Type 1 region bounded on the left and right by vertical lines. Left and right by vertical line. Okay, here is our vertical lines. Okay, so this is a type 1. Okay, so for type 2, bounded below and above by horizontal lines. Okay, so here is our horizontal lines. Okay, this is the type 2. Okay. Okay, look at our example here. Find the volume of the solid that is bounded above by the plane z equals to 3x plus 1 and below by the region enclosed by the parabola y equals to x squared and the line y equals to 2x in the xy plane. Okay, so we just sketch the region R here. Okay, so we have line y equals to 2x. Okay, here is a straight line. Y equals to 2x and sketch the parabola y equals to x squared. Okay, y equals to x squared. So the shaded area here is our region R. Our region R. Okay, this region will give us the information about the limit of integral. Okay, so we also know that our solid is bounded above by the plane z equals to 3x plus 1. Okay, so z equals to 3x plus 1. Our fxy equals to z. Therefore, fxy equals to 3x plus 1. Okay, so for type 1 region, okay, the format should be, okay, since it is vertical, so we should have x equals to what value till what value and y equals to from what function to what function. Okay, so make sure the outside should be a constant number. Okay, so here will be 3x plus 1, okay, which is function f of xy. Okay, here is y, so here should be dy. Here we have x, so here should be dx. Okay, so next what we have to think is what is the value here and here, what is the function here and here. Okay, so Okay, so we have to find the point of intersection in between y equals to 2x and y equals to x squared. Okay, so substitute y equals to 2x into y equals to x squared. Okay, so you will get 2x equals to x squared. Okay, x squared minus 2x equals to 0. Okay, factorize and then solve. You will get x equals to 0, x minus 2 equals to 0, so x equals to 2. Okay, so when x equals to 0, y equals to 2 times 0, so you will get coordinate 0, 0. Okay, so for this one, when x equals to 2, y equals to 2 times 2, which is 4. So the coordinate will be 2, 4. Okay, so we have two intersection points here. Okay, so we can locate these 2 points on our graph for our calculation. Okay, now we are going to locate our points of intersection. Okay, 0, 0 here. Here is 2, 4. Okay. Okay, now let us consider for type 1. Okay, so it should be vertical lines for x here. Okay, so our vertical line is from here and here. Okay, end to end of the region R. Okay, so we know this value is 2 here. Okay, so this line will be x equals to 2. And our line, blue line here is x equals to 0, which is the y-axis. Okay, so we can write down x equals to 0 and x equals to 2. Okay, now for y. Okay, so you have to make a reference line here, which is also a vertical. Okay, at the reference line here, you see which function is above which function. Okay, so we can see that y equals to 2x is always higher than y equals to x squared in this case. So the lower will be y equals to x squared. The upper one should be y equals to 2x. Okay, so what is our function just now? 3x plus 1. 3x plus 1. Okay, dy dx. Now we are going to integrate our double integral. Okay, so equals to Okay, integrate your 3x with respect to y becomes 3xy, and then integrate 1 with respect to y, you will get y. Okay, next, substitute your y equals to 2x plus 2x, then substitute y equals to x squared minus x squared dx. Okay, now simplify. 6x squared plus 2x minus 3x cubed x squared dx equals to 5x squared plus 2x minus 3x cubed dx. Proceed with integration with respect to x. Then you will get 5x cubed over 3 plus x squared minus 3x to the power 4 over 4. Okay, and then substitute the value 2 and 0. Okay, 0 minus 0 plus 0. Okay, and then you will get answer 16 over 3. Okay, we continue our part B using type 2 double integral. Okay, so for type B, we should identify our two horizontal lines. Okay, end to end of our region R. Okay, so we know that the value here is 4. Okay, from here x, y equals to 4 here. Okay, and then here the value is 0. So here will be y equals to 0. For this one, y equals to 4. So our outer integral will be y from 0 to 4. Okay, so the next integral is x equals to what function to what function. Okay, so in order to identify what the function we are going to locate in the limit of integral here, we draw our reference line, which is also must be in horizontal. Okay, so by looking at your reference line here, so we know that the right hand side of the graph, okay, this graph which is on the right is greater than y equals to 2x, because y equals to x is located on the left of the region R. Okay, so the bigger will be y equals to x squared. So here will be x squared. X squared. Sorry. It should be change. We know that it is y equals to x squared, so you have to change in terms of x equals to, okay, so to the left, squared becomes square root of y. Okay, so here will be square root of y. Okay, so on the left is y equals to 2x. This is the right, left. Left function is y equals to 2x, so you also have to change so that the subject will be x equals to y over 2. Okay, so here will be x equals to y over 2. Okay, the function here is z or f of xy, which is x 3x plus 1 dx dy. Okay, x here, y here, y here. Okay, so you just integrate this as usual until you get your final answer to be 16/3. Okay, proceed yourself. So this is our final answer. Okay, the answer from type 2 must be the same with the answer from type 1.